Let's start with this problem. Search in a rotated sorted array. So it's basically the same problem, but the difference is that instead of a normal array, it's a rotated and sorted array. So here is an example of a rotated sorted array, and you basically want to return the index of the target number if it exists, or else -1. You can apply a simple linear search, but that will be big O of n, and that is not required for us since we need to solve it in log of n. So log of n is so binary search should come to your mind, and basically the property of rotated sorted array is that if you apply binary search, you have the low, mid, and high, then you're pretty sure that every time one half will be sorted and other half will be unsorted, right? So that's the trick with most of rotated sorted array problems, that you need to find the sorted half. If you are finding it, then depending on the problem, we need to either search in that or eliminate that, right? So over here, our low is 5, our mid is 1, and our high is 4. Now we can determine that this part of my array, this half, is basically the sorted half, right? So now I need to look if my target number exists in this half. If it does, then I eliminate the left half. If it doesn't, then I eliminate the sorted half. Okay, problem is clear. Now let's code it up. So start by writing your low and high pointers. Low will be 0 and high will be num size -1, the pointing to the last index. Now simple binary search algorithm, low is less than or equal to high. We find out the mid, and low plus high minus low by 2, and if this nums of mid is equal to my target, I return mid. Else I need to find out which is the sorted half now in order to move my pointers. So if my nums of low is less than equal to my nums of mid, then I can know that this is my sorted half. So the next step will be checking if my target exists in this half or not. If it does exist, then it will follow this property. It should be greater or equal to nums of low, and at the same time it should also be less than or equal to nums of mid. If such is the case, then I know for sure that my search number, my target, exists in my sorted half, which is the left half in this case. So which pointer should I move? I should definitely move the high pointer, because now I know that my search space is definitely the left half. If that is not the case, then which pointer should I move? I should definitely move it to the right part, since I know that it does not exist in my sorted half, which is left in this case. So my low will be mid plus 1, right? Now this else is basically if my right half is sorted. If such is the case, then we first check if our target is part of my let me just copy this, it will make more sense. Okay, if my target is basically greater than mid and it is less than high, then I know that okay, my right half is sorted and my target exists in the right part. So I will move my which pointer? Low pointer, which will be my mid plus 1. And if it doesn't, then I know that it exists in the left part and I can eliminate this. So my high will be equal to mid minus 1, right? In the end we return answer. What is answer over here? Let's say that we can declare an answer variable equal to -1, since, yeah, I think this looks correct. Let's try running it. Okay, so we are passing this. What is the time? Let me just go through it again if it is not clear. The problem was to search in a rotated sorted array, and every rotated sorted array can be solved if we find which half is sorted. Because the point of applying binary search algorithm is to get rid of one half of the original array every time. That is why the time complexity is log of n. So in rotated sorted array, we know for sure that one half will be sorted and other half will be unsorted. So depending on it, we apply our binary search algorithm. We first compare if a solution matches with target or not, and then we first check if my left half is sorted. If it is sorted, then this condition should be true. Now, depending on whether our target exists in this half or not, we move the high and low pointers. And similarly for the right part. So this will be right half is sorted. Okay, let's submit it now. The time complexity is definitely big of log n, and that's it.